Now we talk about variance of some continuous random variables. So we start with variance of a uniform random variable. So you have a uniform random variable x. So first you need to find expectation of x square. So x square times, this is the density function of the uniform random variable on the interval alpha to beta. So instead of integrating from minus infinity to infinity, we will integrate from alpha to beta. That is the interval on which we have the probability density function defined. So you know the probability density function for a uniform random variable is 1 over beta minus alpha on the interval alpha beta, and it is 0 otherwise. So 1 over beta minus alpha is constant, so it comes out, and you know integral of alpha to beta x square dx, this is nothing but you have x cubed by 3, and then you go from alpha to beta. So you plug this in, you do the cancellations, you get beta square plus alpha beta divided by 3. So variance of x is expectation of x square, that is this, minus expectation of x square. So you know that if x is a uniform random variable, then expectation of x is nothing but midpoint of this interval, and the midpoint is alpha plus beta divided by 2. So you have expectation of x squared here, so that is why you have alpha plus beta by 2 squared. So you do the computation, you get beta minus alpha squared by 12. Now we compute variance of a exponential random variable x. So again, this exponential random variable x is defined on the interval from 0 to infinity. So that's why you have 0 to infinity, expectation of x square times the probability density function. You integrate by parts, you get 2 by lambda square, and then you write down the formula for variance of x, which is nothing but expectation of x square minus expectation of x square. So this we have just computed to be 2 by lambda square minus expectation of x is 1 by lambda, square this, so you get 1 by lambda square is the variance of the exponential random variable. So variance of the exponential random variable is 1 by lambda square. Now similarly you can compute the variance of the normally distributed random variable. So if x is normally distributed with mean mu and its variance sigma square, you compute its variance, you will find it to be sigma square, precisely this, the sigma square right here. So now we define the concept of a standard deviation. The standard deviation you often denote by this sigma, and this is nothing but it is square root of variance. So you take the square root of sigma square, you get sigma. So this is the definition of standard deviation of a random variable. So first step is you find the variance, then you take its square root, you get standard deviation.